Hello everyone. Today we will going to see some practice questions from the chapter BlockElements, and this is part 2. Let's start. Disclaimer which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of original creators and owners of these images. If you are the owner of any of images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. So this is the index slides. We will going to see some practice questions from question number 10 to question number 18. Let's start with the question number 10. The catenation tendency of carbon, silicon, and germanium is in the order. The most is for carbon, then silicon, and then lowest is for germanium. The bond energies in kilojoule per mole of carbon, silicon, and germanium bonds are respectively. So we have to find out the bond energies of these three bonds. It is given that the catenation tendency order for these three elements is this. Okay, catenation is basically the ability to join or to bonded with a similar atom or element. Okay, so options are 348, 297, 260, 297, 348, 260, 348, 260, 297, or 260, 297, 348. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option A, that is 348, 297, 260. So higher the catenation tendency, higher is the bond energy. This is the concept which we will use here in this question, that if for any atom the catenation tendency is higher, its bond energy will be higher because its tendency to make the bond with the similar kind of atom is higher. Like as the catenation tendency is higher, so therefore the bond energies of carbon, silicon, and germanium bonds will be respectively 348, 297, and 260 kilojoule per mole. Because we just said that the catenation is higher, the bond energy will be higher, and we have asked the bond energies for these three bonds, and we have given the catenation tendency. So similarly, in the same order, the bond energy order will be so higher will be for carbon. So for carbon, it will be 348. For silicon, it will be 297. For germanium, it will be 260 kilojoule per mole. Okay, thus option A is the correct answer. Okay, let's move on to the next question. Question number 11. Strong reducing behavior of H3PO2 is due to. Options are low oxidation state of phosphorus, presence of 2 OH groups and 1 pH bond, presence of 1 OH group and 2 pH bonds, or high electron gain enthalpy of phosphorus. So you have to select the correct reason for the strong reducing behavior of H3PO2 molecule. So you have 10 seconds to solve this question. After that, we will see the correct answer. Okay, let's see. The correct answer is option C, that is presence of 1 OH group and 2 pH bonds. So the presence of 1 OH group and 2 pH bonds the H3PO2 act as reducing agent. Due to these two, if you look upon the structure of H3PO2 molecule, so P will be at the center. It is connected, it is attached, it is bonded with the double bond to the oxygen atom, and one bond is for OH and two bonds are for direct linkage of hydrogen bonds. Okay, so this is the structure of H3PO2, and you can say that one OH group is present and one and two pH bonds are present in the structure of H3PO2, and these are the two main reasons because of which the H3PO2 is acting as a strong reducing agent. Thus, option C is the correct answer. Okay, let's move on to the next question. Question number 12. Nitrogen shows different oxidation states in the range. So, and the question it is given that nitrogen element show different oxidation states. We have to tell the range, that in which range nitrogen show the different oxidation states. Options are 0 to +5, -3 to +5, -5 to +3, or -3 to +3. You have 10 seconds to solve this question. After that, we will see the correct answer. Okay, let's see. The correct answer is option B, that is -3 to +5. So nitrogen show all the oxidation state ranging from -3 to +5 in its compounds. Because if you look upon the electrons present in the nitrogen element, for the nitrogen, 7 number of electrons is present in the nitrogen. So if you write the configuration, it will be 2, 3. Right? So as you can see, 2, 5. Okay, not 2, 3, 2, 5 for the 7 electrons, and in the outermost electron 5 electrons is there, right? So it can gain the 3 more electrons to be stable. So the different oxidation states range start from -3 and it goes to +5. So this is the range that nitrogen show all oxidation state from the -3 to +5. -3, -2, -1, 0, 1, +1, +2, +3, +4, +5. Okay, in its compounds. And thus, option B is the correct answer, that is -3 to +5. Okay, let's move to the next question. Question number 13. A hydride of nitrogen which is acidic is. We have to tell the hydride of nitrogen which is acidic in nature from the options. Options are NH3, N2H4, N2H2, or N3H. Choose the correct one, and you have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option D, that is N3H. So N3H, from all the options, N3H is acidic because it can donate protons, and it shows the following resonating structures. You can see these two structures of N3H, like triple bond between 2N and single bond between 2N. Similarly, triple bond between 2N, single bond between 2N. And the place of charge is changing accordingly in these two resonating structures. Right? So, from the given options, N3H is acidic as it can donate protons, and it also exists in the resonating structure, in the form of resonating structures. Thus, option D is the correct answer, that is N3H is a hydride of nitrogen which is acidic. Okay, let's move to the next question. Question number 14. The compound that does not produce nitrogen gas by the thermal decomposition is. So from the given options, we have to tell that which compound does not produce nitrogen gas by thermal decomposition. If we do the thermal decomposition of these, which will not produce the nitrogen gas, that will be our answer. Options are BaN3 whole twice, NH4 whole twice Cr2O7, NH4NO2, NH4 whole twice SO4. So you have 10 seconds to solve this question. After that, we will see the correct answer. Okay. Let's see. The correct answer is option D, that is NH4 whole twice SO4. So the thermal decomposition of given compounds is shown below. So for the NH4 whole twice Cr2O7, it will, on the thermal decomposition, it will give nitrogen gas plus 4 molecules of water plus Cr2O3. For NH4NO2, on the thermal decomposition, it will give N2 molecule and 2 molecules of water. For NH4 whole twice SO4, it will give us 2 NH3 molecule and 1 H2SO4. You can see here that there is no production of nitrogen gas. While in case of BaN3 whole twice, we have 1 Ba molecule, 1 Ba atom or 1 Ba element plus 3 molecules of the nitrogen gas, right? So on except this compound, all other compounds on the thermal decomposition gives us nitrogen gas, produce nitrogen gas, right? And thus only NH4 whole twice SO4 does not give N2 on heating, while rest of the given compounds give N2 on their thermal decomposition. Thus, our correct answer is option D, NH4 whole twice SO4. Okay, let's move to the next question. Question number 50. Extra pure N2 can be obtained by heating what? Okay, so if we want to find out the extra pure nitrogen, so through the heating of which compound we can find it? Options are NH3 with cuprous oxide, NH4NO3, NH4 whole twice Cr2O7, or BaN3 whole twice. You have 10 seconds to solve this question. After that, we will see the correct answer. Okay, let's see. So the correct answer is option D, that is BaN3 whole twice. So this will be the reaction following that BaN3 whole twice on the heating. It is giving us Ba atom and plus 3 molecules of N2, or you can say N2 gas. Okay, so azide salt of barium can be used to obtain purest form of nitrogen. The decomposition product contain solid barium as byproduct along with the gaseous nitrogen. You can see in the reaction. So, okay, thus the D option is the correct answer, that is BN3 whole twice, because only this can produce extra pure N2 by heating. Okay, let's move to the next question. Question number 16. The number of sigma bonds in the P4O10 is. So we have a molecule here, P4O10, and we have to tell the number of sigma bonds present in the P4O10 molecule. Options are 6, 16, 20, or 7. You have 10 seconds to solve this question. After that, we will see the correct answer. Okay, let's see. The correct answer is option B, that is 16. So the number of sigma bonds in P4O10 is 16. There are also 4 pi bonds present in the P4O10 molecule. This is the structure of P4O10 molecule. So you can see 1, 2, 3, 4. 4 phosphorus is present. Oxygen will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oxygen is 10. Now, as you know that all the single bonds are sigma bonds, and in the double bond, one bond is sigma bond and other bond is pi bond. So if you count the sigma bonds number, the number of sigma bonds, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 12 plus 4 will be 16, because one each from the double bond, and the other rest double bond other rest bond present in the double bond other than the sigma bond is pi bond. That's why it is written that 4 pi bond is present in the P4 O10 molecule, because from these 4 double bonds, in each of these 4 double bonds, this one bond is sigma bond and one bond is pi bond. So there are total 4 pi bonds, and in the whole structure we have 16 number of sigma bonds in the P4 O10 molecule. Okay, thus the B option is the correct answer, that is 16. Okay, let's move to the next question. Question number 17. pH 3, the hydride of phosphorus is. So we have to select the correct one, which is matching here, which is filling here from the options. So pH 3 is a hydride of phosphorus. The nature of this will be. Options are metallic, ionic, non-metallic, or covalent. You have 10 seconds to solve this question. After that, we will see the correct answer. Okay, let's see. The correct answer is option D, that is covalent. So pH 3 is a covalent hydride. Okay, it is the property of pH 3. It is the characteristic of pH 3 that pH 3 is a hydride of phosphorus which is covalent in nature, because covalent bonds are present in the pH 3 molecule. Thus, our D option, that is covalent, is the correct answer. Okay, let's move on to the next question. Question number 18. When the concentrated HNO3 is heated with P2O5, it forms. So what it will form when these two react with each other or heated with each other? Options are N2O, NO, NO2, or N2O5. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option D, that is N2O5. So this will be the reaction: 4HNO3 plus 2P2O5 on heating, giving us 2N2O5 plus 4 molecules of HPO3. Right? So this will be the reaction, and we can see that we have obtained the 2 molecules of N2O5 when we reacted or heated concentrated HNO3 with P2O5 molecule. Right? So the main product is N2O5. Thus, option D is the correct answer. Okay. Thank you.